Lunch and Learn is an MFG radio network production brought to you by GIE Media's Manufacturing Group. We highlight some of the latest innovations in manufacturing and design to help you gain insights to the newest products and technologies in the medical, aerospace, defense, and electric vehicle manufacturing industries to keep you ahead of the competition. Hello and welcome to our latest and last Lunch and Learn of 2025. I am Jake Kaufman from GIE Media's Manufacturing Group of Magazines. I am the senior editor here, and we are happy to be joined today by Fagor Automation. Fagor Automation is a company with great experience in the development and manufacturing of products for machine automation and control. It excels at its capability to develop software and the versatility of its productive process to offer solutions tailored to the needs of their customers. Historically, Fagor Automation has focused efforts on the machine tool sector, where they are one of the world leaders. Besides its wide technical sales network spread out in more than 50 countries through its own branch offices and distributors. Today's presentation, CNC machine accuracy, repeatability, and reliability, will be handled by Alejandro Escamilla. He is the National Product Manager of Feedback and Smart Encoder Systems at Fagor Automation. Alex has been in the CNC industry for more than 25 years. He has since become the leading optical encoding expert at Fagor Automation North America, focused on generating solutions for unique customer applications requiring accuracy and dependability. Now it's time to hand things over to Alex and also Ryan Adamovic, the marketing manager over at Fagor Automation. So gentlemen, the floor is all yours.
Hello everyone, and welcome to today's Lunch and Learn webinar hosted by GIE Media. I'm thrilled to see so many of you here to explore what is truly an essential topic for anyone involved in CNC machining, whether you're an OEM, integrator, or machine operator. As the pace of manufacturing continues to accelerate, so does the need for uncompromising precision in CNC processes. Achieving that level of CNC precision is no longer just a nice to have. It's a critical factor that can make or break competitiveness, especially in industries where quality control and performance are non-negotiable. In previous webinars, such as our Fundamentals of 5-Axis Machining, we discussed different CNC control algorithms that improve accuracy, such as high-speed surface accuracy algorithms, volumetric compensation, and dynamic machining control. But utilizing CNC control algorithms alone will not achieve the level of precision needed for today's tight tolerances. Today, we'll be focusing on a technology that is at the heart of this precision: linear and angular encoders. Encoders play a fundamental role in providing accurate positioning feedback, allowing CNC machines to perform with the repeatability and accuracy required by today's demanding applications. But as those of you who work in the CNC industry know, it's never quite as simple as just adding a component and expecting perfect results. Accuracy and repeatability in CNC operations are continuously tested by factors. Factors such as thermal expansion, which can subtly distort dimensions, mechanical misalignments, which throw off positioning, and the unavoidable impact of vibrations in high-speed operations. Overcoming these challenges is essential for those of us aiming to achieve peak CNC performance day in and day out. In just a moment, we'll dive deeper into this topic with today's featured presenter, Alejandro Escamilla. Alejandro brings 25 years of the expertise in precision and feedback technologies and their applications of CNC machining. He'll be walking us through the common challenges to CNC machine accuracy and introducing us to the advanced encoder technology that addresses these issues. He will also be discussing some elements exclusive to Fagor encoders designed specifically to target those issues more aggressively. Whether you're looking to improve consistency, troubleshoot accuracy challenges, or simply stay on the cutting edge of CNC technology, you'll gain valuable insights from his presentation. Without further ado, please join me in welcoming Alejandro Escamilla.
Thank you, Ryan. To set the stage, we will start with a technical overview of Fagor linear encoders. In today's modern machining of high accuracy complex parts, over 95% of the machine tool makers use enclosed absolute optical technology on their linear and angular encoders for position feedback. Absolute encoders offer many advantages over the incremental encoders, such as knowing the position at all times, including at power-up. This is a very valuable feature, especially for large machines. Absolute encoders also offer their latest mechanical and electrical technologies, such as Fagor's 3-state tech anti-contamination technology. They offer higher resolutions compared to incremental encoders and are more applicable with their absolute signals to various control protocols. You will also find non-contact linear encoders like exposed linear encoders and angular rotary feedback for applications such as CMM machines or microprocessing machines. Let's examine the measurement standard. These encoders use precise optical technology with a grading period of 20 micrometers, which is instrumental in enhanced measurement accuracy. The lower the grading period provides finer measurement resolution, leading to greater precision. Focusing on the engraving methods. It's important to ensure that the engraving method on your glass scale is consistent. This uniformity directly translates into more accurate and reliable position data. The clear and uniform etching allows for straightforward data interpolation without relying on extra processing steps. By contrast, other encoders design often use non-uniform engraving, which results in scattered data points. The encoder must utilize complex algorithms to compute position data, adding processing time and increasing the risk of errors, which can negatively impact CNC machine performance and reduce overall efficiency. This is why Fagor enclosed encoders all feature uniform engraving. In CNC machining repeatability, the ability to achieve the same position across multiple cycles is just as important and crucial as accuracy. Here, ultra-low subdivisional error, also known commonly as interpolation error, helps maintain consistent, precise signals, allowing for repeatable position for the encoder. Consistent readings are mandatory for reproducing parts of the same specification over and over, minimizing variation and providing high-quality finish in demanding applications. Additionally, Fagor glass scales are engineered with a stable thermal expansion coefficient, specifically 8 parts per million per Kelvin. This factor is essential because in high-precision CNC application, even minor thermal fluctuations can lead to errors in dimensions. In high-precision CNC environments, several sources contribute to these temperature fluctuations, potentially impacting position accuracy. For instance, friction in the ball screw mechanism can generate heat, especially when machining heavier parts. Motor heat dissipation and high-energy machine components also add to thermal load to the system, and even environmental factors like summer temperatures can affect machine stability. When temperature changes occur, components such as ball screw and machine structures may expand or contract, influencing position accuracy. Direct measurement methods are particularly effective for addressing these thermal impacts, as they reduce inaccuracies that arise with indirect measurements. This is why it is important to utilize glass scales rather than steel tape for high accuracy machining, even if the encoder is enclosed. Our encoders utilize glass scales due to low thermal expansion coefficients, ensuring that the scale remains stable when the machine itself experiences expansion. This ability allows the reader head to consistently scan the scale, maintaining accuracy along its full length regardless of temperature shifts. Additionally, a thermal determined mounting system, such as the one found on our encoders, is designed to synchronize with the machine thermal movements by allowing the extrusions to expand and contract along with the machine base. The mounting system supports accurate positioning without warping or misalignment from temperature changes. This careful attention to thermal management helps maintain CNC accuracy and ensure reliable, repeatable measurements even under varying thermal conditions. Mechanical stability within the encoder setup is essential, especially in environments with frequent or rapid axis movements. Encoder mechanical design isolates the reader head from the axis deviation, meaning that the harmonics from the machine do not affect the encoder's readings. This stability supports more accurate, reliable data in dynamic machining environments, helping to keep measurement precise even when the machine undergoes quick changes in direction and acceleration. There are two major methods when it comes to mechanical stability of the reader head: guided style and floating style. Guided style compensates vibration in 3 axes, resulting in a more robust design for mounting on the machine. Floating style, on the other hand, was designed for vibration compensation for only a single axis, leaving the other 2 without compensation. Loop time is a critical metric for CNC machines, reflecting how quickly the encoder can process and update position data back to the CNC control. In high-speed or high-precision environments, faster loop time translates into smoother and more responsive control over the machining movements, resulting in a mirror-like part finish. With a response time of under 5 microseconds, encoders can better support precise and stable operation, a significant factor in maintaining quality in demanding CNC operations. Our encoders can provide real-time position by reading the position every microsecond and communicating the position in just under 5 microseconds. On the other hand, some other brand encoders provide the position up to 31.3 microseconds, 6 times slower than Fagor. This is because the reader head has to complete a CCD scan with thousands of data points, calculate the position, and estimate the change in position since the initial CCD scan. Because our encoder does not rely on position estimation, it would be valid for modern CNC time loops, while other encoder brands with a slow loop time would be a choking point to the CNC. Let's look into why this critical difference can present a problem. Real-time CNC feedback is fundamental to CNC accuracy, as it allows for precise control and synchronization across multiple axes. Encoders that provide instantaneous position data can eliminate position error and ensure more accurate measurements. Real-time sampling minimizes potential errors by estimating inaccuracies, such as those caused by change in acceleration, something especially beneficial in applications requiring synchronized motion and high-speed algorithms. Let's look at an example of a real-time position provided by encoder compared to another encoder that utilizes estimated position calculations. The blue plot line represents the instantaneous real-time position sampling of one position per micrometer. The orange line represents another encoder brand that relies on estimated position due to slow loop time. If the CNC is requesting a report of the position every 40 microseconds, there will be a substantial difference between estimated position and real-time position when rapid changes in acceleration are encountered. When designing your CNC application with encoders, you should consider encoders with a closed loop sampling rate of one position per 5 microseconds or less. This will lead to near instantaneous position data with no estimation, guaranteeing your application is free of time-dependent position errors. One of the often overlooked aspects of encoders is their resistance to contamination and the ability to withstand adverse conditions. Materials like coolant and dust can interfere with sensitive components, so a protective design is key to keeping encoders functioning correctly over time. When a machine is powered on with active coolant, lip seals for encoders are the first and primary barrier preventing coolant from getting inside the encoder. Fagor encoders are designed with a high fluoropolymer sealing lip that shield internal components from dust, coolant, and other contaminations common in machining environments. This design enables extended maintenance-free operation, helping to reduce downtime and operational cost over time. Unlike alternative encoders that require a double sealing to achieve similar protection, Fagor's single lip seal design achieves the high resistance with minimal friction, enhancing performance while ensuring durability under the challenging conditions. However, when the machine is powered off for the evening or weekend, the coolant can vaporize and work its way into machine components, including the encoder. In absolute encoders, both linear and angular, the absolute position is calculated via a binary code of ones and zeros, similar to a barcode. This binary code is unique along the entire length of the scale. The encoder is able to calculate the absolute position by reading these ones and zeros. With traditional technology, if there is any contamination on the etching of the glass, the ones and zeros become less distinct. A 0 can be seen as a 1, and a 1 can be seen as a 0. In these cases, the encoder may have difficulties in determining the absolute position, generating an alarm, and consequently stopping the machine. Traditionally, an air purge would be used to overcome any contamination of the scales. Compressed filtered air is used to pressurize the extrusion to keep out contamination from ever reaching the optical glass. Something to keep in mind, the air purge solution is only as good as the maintenance and the quality of the air provided to the scale. It is critical to constantly replace your filters and prevent buildup of condensation inside the air lines. Another factor to keep in mind is that the air purge is not active when the machine is not powered on. As a result, any remaining coolant evaporates, and without pressurized air, the scale has the possibility of being contaminated with condensation. You may be wondering, does my machine application require air purge? Are there any solutions that are less complicated? The necessity of air purge depends on the scale location within inside the machine frame, especially in environments where the coolant comes in direct contact with the scale body, the most demanding work conditions. In these situations, we would strongly encourage that all encoders, no matter the manufacturer, take advantage of the air purge to benefit from the performance of the scale. In cases where the scale is installed in an area where coolant does not directly impact the scale body, air purge is unnecessary while utilizing Fagor's three-state technology. But before we get into that, another technology that Fagor has implemented to combat condensation is known as sensor compensation. This is an advanced software and electronics that self-regulate the intensity of the specialized photodiode reading, allowing us to maintain a consistent signal. The LED typically functions at 60% power. When the etching of the glass is obstructed by contamination, the LED self-adjusts to overcome and read the binary code. To provide you with the most dependable technology against contamination, pollutants, and vapors, a new solution has been developed that utilizes a third state to determine the absolute positioning. This new technology is called three-state technology. Three-state technology consists of a pseudo-random engraved code and the imaging technology that generates 3 different states if contamination is present on the track. This allows the system to discard the erroneous information, so only valid information is used to calculate the absolute position. Utilizing the embedded algorithms, the correct position is calculated with less information, yielding a more dependable encoder. Inaccurate position data resulting from the condensation is disregarded during the calculation of the absolute position. This is achieved through the utilization of advanced embedded algorithms in conjunction with three-state CCD camera. The algorithm swiftly processes a 48-bit image to identify any questionable code in the absolute track due to contamination. This excessive optical technology guarantees flawless performance even when exposed to coolant contamination. Fagor tested encoders equipped with this technology on machines with a coolant-enriched environment for over 53 weeks. The machines were powered off on Friday and powered on Monday again, simulating standard machining hours. During the 53-week test, the encoders were exposed to various contaminations without positioning errors. The test results provided that three-state technology can contend with contamination-rich environments. If you are in the Chicagoland area, I would be happy to welcome you to the North American headquarters so I can give you a tour. We also offer product demos and training at this facility, as well as our offices in Anaheim and Toronto. It has been a pleasure to present to you our latest innovations. My colleagues and I will answer any and all of your questions. Thank you for joining us.
Awesome. Well, Alex, thank you so much for that presentation, and thank you so much for joining us now. We do have a few questions coming in. So it looks like the first one that we got from Dave is, can legacy machine tools be retrofitted with these modern encoders?
So it depends, depending on the control that's mounted on there. It could be if it's a FANUC control, if it's a Fagor control. I would need to know more information when you say a legacy control.
Okay. If it is a Fagor control, would that be?
So you can use, for example, a Fagor 8055 CNC. If you have an AXD drive, you are able to connect the uh, absolute linear encoder to the drive itself, and then via circles, it'll talk to the 8055.
Gotcha. Looks like Larry wants to know, what is the maximum length of an absolute linear encoder?
Okay, in glass, we can reach lengths of 3 meters. Beyond 3 meters, we need to change over to steel tape. And presently, Fagor can offer an 83-meter long scale in
Okay.
absolute protocol.
No, that's a big boy right there.
Oh, yeah.
Gotcha. Looks like, okay. Eric says that he has a 20-year-old Lucas boring mill that has incremental scales. If he retrofits with absolute scales, what sort of improvements could he expect?
Well, you're going to get much better resolution with it. We've also provided a poly, it's a Viton material on the ceiling, so it's more resistant to chemicals. Also, we have a new technology that's called three-state tech, which is basically we're able to detect any contamination on the scale and eliminate any possible errors that we may be reporting to the CNC itself. Now, doesn't mean that it's impervious to contamination, but we're able to resist more contamination prior to providing any sort of maintenance to the machine.
Gotcha. And it looks like Tommy has a question about, can encoders be integrated into predictive maintenance systems or Industry 4.0 applications?
So, presently we have a device called a PSED that you can see how good the signal strength coming off the scale is. So, you can technically put in, let's say every 3 months and kind of see how well that signal is before you have to take the machine down for any maintenance or have an error, preventing you from uh, uh, manufacturing on that particular machine.
Okay, gotcha. Well, yeah, there are still a few minutes if anyone has any other questions for Alex. But if there are no more, I just want to say thank you so much, Alex, for your time today. Thank you to the whole team at Fagor Automation. I hope you have a very Merry Christmas, Happy New Year, and Happy Holidays coming up.
Thank you. You as well.
You can listen to all of our episodes of Manufacturing Matters and Lunch and Learn podcast from the MFG Radio Network on Spotify, Apple Music, and on our websites, today'smedicaldevelopments.com, aerospacemanufacturinganddesign.com, defenseandmunitions.com, and evdesignandmanufacturing.com.